Welcome to the Space Oddities series of Astronomy Basics videos. In this video we're going to be asking the question, what is a magnetar? A magnetar is the most magnetic object known in nature, a type of neutron star with an extremely powerful magnetic field. The magnetic field of a magnetar can be up to 100 trillion times stronger than the magnetic field of the Earth. A magnetar at the distance of the Moon could pull the keys from your pocket or wipe the magnetic strip on your credit card. If you approached a magnetar to within 600 miles of its surface, its magnetism would, quite literally, dissolve all the atoms in your body, leaving you as just a cloud of electrons and ions. Magnetars have distinct properties which distinguish them from other astronomical objects. They are a type of neutron star, but with a few differences. They're very dense. A magnetar has a mass about 1.4 times that of the Sun, but it's only about 20 kilometers in diameter. They're very hot. The surface temperature of a magnetar can be up to 100 million degrees Celsius, and magnetars are very fast rotating. A magnetar can rotate once every few seconds. However, although magnetars are very similar to a typical neutron star, a magnetar can emit up to 100 times more energy. So how do magnetars form? Up until very recently, it was believed that magnetars are the result of a red giant star ending its life in a supernova explosion, leaving behind its ultra-dense core. In other words, a magnetar is a neutron star, much the same as others, but with the addition of an incredible magnetic field. However, recent research seems to suggest that in fact magnetars may not result from red giants at all, but from another, rare type of star. The most recent research into the origins of magnetars has focused on a new type of star called a massive magnetic helium star. These stars are a few times more massive than the Sun and are rich in helium. They are also thought to have very strong magnetic fields. In a study published in the journal Science in August 2023, astronomers found that a massive magnetic helium star called HD 45166 is likely to become a magnetar. The star is located about 3,000 light years away from the Earth in the constellation of Monoceros. The astronomers studied the star using multiple telescopes, including the European Southern Observatory's Very Large Telescope. They found that the star has a mass of about 3.5 solar masses and a surface temperature of about 20,000 degrees Celsius. Astronomers believe that massive magnetic helium stars must be rare, because to date only around 30 magnetars have been discovered in our galaxy. However, as yet astronomers know little about these strange stars and the process whereby they form magnetars, if indeed that's what they do, which is by no means certain at the moment. Far more research is needed to establish why these stars have such strong magnetic fields in the first place. Magnetars and fast radio bursts. Fast radio bursts, or FRBs for short, are bright bursts of radio waves that come from distant galaxies all over the sky, their distribution seemingly random. They typically last for just a few milliseconds and can carry more energy than the Sun puts out in a year. They are incredibly mysterious and their origin is still unknown. However, there is growing evidence that magnetars may be the source of FRBs. There are several lines of evidence that support the link between magnetars and FRBs. First, the timescales of FRBs and magnetar outbursts are similar. Second, the locations of FRBs are consistent with the locations of magnetars. And third, the energy emitted by FRBs is similar to that emitted by magnetar outbursts. In 2020, astronomers detected a bright radio burst from a magnetar called SGR J1935+2154, which is within our own galaxy, the Milky Way. This burst was very similar to an FRB, and it provided strong evidence that magnetars can indeed be the source of FRBs. However, not all astronomers are convinced that magnetars are the only source of FRBs. Some astronomers believe that FRBs could also be caused by other objects, such as neutron stars with weaker magnetic fields or black holes. More research is needed to definitively determine the origin of FRBs. However, the evidence is mounting that magnetars are a likely culprit. Here are some of the key similarities between magnetars and FRBs. Both are extremely energetic, both are short-lived, both are thought to originate from distant galaxies, both are thought to be caused by magnetic fields. However, there are also some key differences between magnetars and FRBs. Magnetars are known to exist while FRBs are still a mystery. Magnetars are thought to be relatively rare, while FRBs may be more common. Magnetars emit a wide range of frequencies, while FRBs are only seen at radio frequencies. The link between magnetars and FRBs is a hot topic of research in astronomy. As more FRBs are discovered and studied, scientists will be able to better understand these mysterious objects and their origins. Well, that brings us to the end of this brief introduction to magnetars, but just to summarise, magnetars are neutron stars with incredibly strong magnetic fields. Their origins are uncertain, but recent studies link them with a new type of star called a massive magnetic helium star. Magnetars may be the source of fast radio bursts, or FRBs, those enigmatic and powerful bursts of radio waves of incredible power seen all over the sky. Much is still unknown about magnetars, but they seem to be very rare animals in the cosmic zoo. Well, we hope you've enjoyed this video about magnetars. Do keep your eyes open for other videos in the Astronomy Basics series from Space Oddities on our YouTube channel. Until the next time, goodbye.